In this video, we're going to look at expanding, and in particular, two methods that we can use to expand. The first is the distributive law, and then we'll look at FOIL. So the distributive law is used when you have equations in the form of A times B plus C. Now what this equals is A times B plus A times C. And what's happening is A is being distributed into each term in the brackets. So let's have a look at an example with some numbers. So we have 3 multiplied by 2 plus 4. Now, according to our distributive law, this is equal to 3 times 2 plus 3 times 4. This will give us 3 times 2 is 6, 3 times 4 is 12, 6 plus 12 is 18. And this is correct because if we look at it from, our normal standpoint, without knowing the distributive law, we would go 2 plus 4 is 6, because that's in the brackets. We always do our brackets first in order of operations. And then we multiply that by 3. 3 times 6 is also equal to 18. So that shows that our distributive law works. So when you're using it, you're probably more likely to see it in algebra context. So let's have a look at an algebra version of the distributive law. So if we have 2 multiplied by x plus 4, well, we know that this is the same as going 2 multiplied by x, which is just 2x, plus 2 times 4, which is 8. So from the distributive law, we know that 2 times x plus 4 is the same as 2x plus 8. Let's look at another example using a negative. So we have 2 times x minus 4 this time. 2 times x is 2x, and then 2 times negative 4 is negative 8. So we need to make sure that we take into account the negative signs in our expressions. Let's look at one more type of distributive law, and that's when we have a variable outside of the brackets. So we have x multiplied by x minus 5. Now we know that x times x is x squared. X times negative 5 is negative 5x. So expanding x times x minus 5 gives us x squared minus 5x. So these are some of the ways that you can use the distributive law. And it all comes back to this rule at the top, that we just distribute whatever on the outside of the brackets into each term within the brackets. Be careful, because a lot of students make the mistake is they'll multiply a times b, but they'll forget to do the a times c. So make sure you're being really careful when you're using this law. Okay, now let's look at FOIL. So FOIL is used when we want to expand two binomial expressions being multiplied by each other. So it is in the form of x plus a multiplied by x plus b. Remember that a binomial expression is just an expression that has two terms. So in this case, our first bracket, the two terms are x and a, and in the second bracket, our two terms are x and b. So they are both binomial expressions, and we're trying to multiply them together. So FOIL is actually an acronym that stands for the order in which we expand. So we start with first. And what that refers to is the first term in each of the brackets. But we'll get to more detail on that in a moment. Then we have the outside. Outside. Then we have the inside. And then last. Okay, so if we were to expand what I've written above here, we're going to start with the first term in each bracket. Now, the first term in each bracket is x. So we are going to multiply x times x. Then we are going to multiply the outside. Now, the outside are the two terms that are on the outside of these bracket multiplications. So that, in this case, is x in the first bracket and b in the second bracket. So we're going to add x times b. Now, next is our inside. So we're going to multiply the two terms that are on the inside of each of the brackets. And in this case, it's a and x. So we're going to add a times x. Finally, we're going to multiply our last term in each bracket. So here we have a and we also have b. So we have plus a times b. Now we can simplify this and we will get x times x, which is x squared, plus x times b, which is bx, a times x, which is ax, and a times b, which is ab. So that is expanding using FOIL. So let's look at an example with some numbers and see how we go. So let's expand the expression x plus 2 multiplied by x plus 3. Now, we're going to start by multiplying our first term in each bracket, which is x times x, which is x squared. That is x times x. We are then going to do our outside. Now, our outside terms are x in the first bracket and 3 in the second bracket. And that is 3 times x, which is 3x. Next, we're going to do what's on the inside of each bracket. So we have 2 and x. 2 times x is 2x. And last is going to be our last term in each bracket, which is 2 and 3. 2 times 3 is 6. Now, hopefully you're looking at this and noticing that we can collect some like terms here, because 3x and 2x are both like terms. So we are going to simplify this expression by going x squared plus 3x plus 2x is 5x plus 6. And that is the expanded version of x plus 2 and x plus 3. Let's look at another example. So we're going to expand x minus 3 and x plus 2. If you'd like to try this on your own, I'd encourage you to pause the video now and then play once you've had a go and then see if you were correct. But if you are still wanting a bit more help, this is how I'd go about this expression. So first, x times x, that is giving us x squared. Outside, x times 2 is 2x. Inside, negative 3 times x, that is minus 3x. Then last, negative 3 times 2 is negative 6. Once again, I can collect some like terms here. X squared, 2 minus 3 is negative 1, so that's just negative x minus 6. And that is the expanded version of x minus 3 times x plus 2. I'm going to go through one more example, and this particular example combines both the distributive law and FOIL. So we're going to use 4 times x plus 3 multiplied by x plus 5. So you have two options when you approach expressions like this. The first is you can expand using FOIL first and just keeping 4 out of it to start with, then multiplying it in at the end. Or you can start by using the distributive law with 4 times x plus 3 and then expand using FOIL from there. I'm going to use the second option, but both options will give you the exact same answer, so it's completely up to you. But I'm going to start by multiplying using the distributive law. So I'm going to have 4x plus 12 multiplied by x plus 5. Okay, so now I've got my two binomial expressions, and I can expand using FOIL. So first, 4x times x is 4x squared. Outside is 4x times 5, which is 20x. Inside is 12 times x, which is 12x. And last is 12 times 5, which is 60. Now, we once again can collect like terms and get 4x squared plus 32x plus 60. And that is the expanded expression of 4 times x plus 3 times x plus 5. Now, I encourage you to practice this further. It's a really key skill in algebra and in quadratics if that's what you're moving into. And really important that you nail before moving on. Okay, so now we're going to look at how we expand on the TI N-spire CAS calculator. So it's really simple to do. What you need to do first is go to Menu, 3 for algebra, then 3 for expand. So menu 3, 3. So remember, just press the numbers. Don't bother scrolling down. Just go menu 3, 3. And you'll get this, expand. And then you just type in your equation. So let's say I wanted to do 3 times x plus 4. It'll expand it for me to 3x plus 12. If I go again, menu 3, 3, and I want to put in 4 times x minus 7 times x minus 23, it will expand that for me.